Okay, so this is question 2 from the free response portion of the practice test. In this question, I want to give you caution that you probably will see a question like this on the AP exam. It's generally the first question. You may even see it on the next test. Hint, hint, nudge, nudge. So most of you got A correct. When they ask you to find how many gallons were in the tank during the interval, and you recognize that this is a rate, so essentially this is the derivative. So to find the total amount in the tank at the end of 4 hours, what we would do is we would integrate from 0 to 4, and we would integrate E of t. Now, it is perfectly fine to write this expression this way and just use your calculator to give you the answer, which is 3981. Generally, on the AP exam, as long as since they define E of t and you define E of t here, this is correct nomenclature, and you'll get full credit for this. Also on the AP exam, they love to give you these ugly functions and ask you either to integrate or differentiate. And what you want to be able to do is do this on your calculator. If you cannot do this on your calculator, you really need to come see me and let me show you how to do that before the AP exam, really before the next test. So for this question that was worth 2 points, you got 1 point for the integral, which I thought was pretty generous, and you got 1 point for the answer. And most of you got both of those points. The second question asks us to find when the sewage is at a maximum, okay? So the first thing we need to do is write an expression for how much sewage, the rate at which the sewage is entering the tank. And this is where most of you made your mistake, not recognizing that 645 is in of itself a rate. So you did not have to add t to that. So how much is in the tank at any time is given by E of t minus 645. So this is equal to the amount in the tank at any time. So you got 1 point for writing this expression. A lot of you lost that point because you put a t on 645. But 645 is a rate, so no t goes with it. So it's simply E of t minus 645, and that was worth 1 point. So to find when this was at a maximum, I'm sorry, you got 1 point for writing this expression and setting it equal to 0, because this is the derivative. This expression represents the derivative. So to find my critical numbers, I have to set this equal to 0. So finding when this is equal to 0, my critical numbers become t is equal to 2.309 and t is equal to 3.559. Now, how do we know which of these is a max or a min? Well, we have to recognize that this is on a closed interval. Because it's on a closed interval, we have to also consider the endpoints. Second time we've had to do that. We have to consider the endpoints. And then we need to see how much is in the tank at each of these times. If you graph this, you may see that I think this may be a local min. So you really don't have to consider this one if it's a local min. However, you did have to find it. So because we know that this is a local min, we don't have to do anything when we put it in our table. But if you weren't sure, you could also add it to the table. So I'm just going to do 0 to 2.309 and 4. So we know at 0, there's 0 amount in there. How do we find how much is in there at 2.03? Well, we would integrate from 0 to 2.309 E of t minus 645. And that gives us 1637.178. And then to find out how much is there at 4, because we have to consider the endpoint, we have to integrate from 0 to 4 E of t minus 645, and we find that to be 1401.022, and therefore this is our maximum value. So where did our points come from? You got 1 point for setting E sub t minus 645 equals 0. That was 1 point. You got 1 point for identifying your zeros. There's 1 point here. You got 1 point for finding 1637. And you have 1 point for your conclusion. And your conclusion is at 2.309 hours, you have the maximum amount of 1637.78 in the tank. No one got that. Most people got at least this 1 point. Some people got that, but I don't think anyone got all 4 points. Okay? The final question on this, again, you have to remember that the integral of A times B is not equal to the integral of A times the integral of B. And a lot of you did this on this question and got the wrong answer. So really, if this is the cost per gallon, then to find the total cost, I would have to multiply this expression by E sub t and integrate it. I cannot take integrating, so a lot of you took the answer you got here and multiplied it by this integration. That will give you a different answer. So your answer is actually the integral from 0 to 4 of E of t times 0.15 minus 0.02t. And the answer to that is 474. So you got 1 point for your limits, which most of you got. Very few people got the integral. And then, of course, 1 point for the answer. And that is problem 2. Problem 3 will be up shortly.